Okay, so this time around, we're actually looking at the polar coordinates, and use the indicated format. So in our case, we're going to look at degrees, just because there are so many different angle measures out there, right? So find this in degrees, and you want it to be within one positive rotation. So in this particular question, we're looking for an angle between 0 degrees and 360 degrees, and I could put we're equal to there. Okay, so this means this is given as rectangular, meaning this is x and this is y, and we're looking for polar. So our goal is to find r and theta. So it takes a tiny bit more work than the other one, not a tremendous amount of work by comparison, but a little bit more. In order to find r, we use our favorite r is equal to x squared plus y squared. It's a half sibling to the Pythagorean theorem, looks a lot like the Pythagorean theorem. So we're going to get r is equal to -3 squared plus 3 squared square rooted. R is going to be equal to the square root of, this is 9 plus 9. R is equal to the square root of 18, which if I factored 18, I would get 9 times 2, which means this is 3 square root 2. And yes, you do need to simplify that radical if at all possible. So 3 root 2. Pretty straightforward for r. When it comes to theta, again, not a drastic amount of work by comparison, but a lot of times we kind of have to work backwards to find theta, and we were given a couple of identities, I suppose, in our definitions here. We have r is equal to, that is, we have x is equal to r cosine theta. That's one identity. Only problem is I don't know theta. We have y is equal to our sine theta, right? But we also have tangent theta is equal to y over x. And I sort of wrote an r there. That should be an x. And usually this is the identity that we use. So we start off with tangent theta is equal to y over x, and we plug in. So I don't know theta at the moment, but I do know y, that's 3, and I do know x, that's -3. So I'm looking at tangent theta is -1, or theta is tangent inverse of -1, right? So where is tangent equal to -1? And you can use some of your properties, be a little careful with how you approach them. You can use kind of a reference angle approach where you're really asking, where is tangent equal to 1? And then you adjust for the quadrant. That would be okay. As I look at this and as I ask this question, I actually want to be very conscious of where my point is located. So if we were to graph -3, 3, 1, 2, 3, 1, 2, 3, this would be the point that we're talking about here. So this is -3, 3, and we're trying to find the polar coordinate representation of that. That is actually going to give me quite a bit of information, because if you remember when we did our equations with these trig functions, we could have multiple answers, right? Remember, you would say, you get your angle plus, because it's tangent, pi times n for some integer value of n, right? And you have to be considerate of multiple answers, especially because it's tangent, because tangent only has a period of pi, not that full rotation. So when it comes to this question of what angle am I looking for, it seems like more than one could be the answer. You're right. More than one could be the answer. So I'm going to be very conscious that this lands in the second quadrant. This is the value of r that I did not draw straight at all, but we just found 3 root 2. And what we're looking for right now is what angle measure takes us here, right? Again, I'm going to use reference angles to kind of help me out. The left-hand rule helps out a bit here because I want to know essentially when is cosine equal to sine. because that's when I get 1 out of the deal, and then the negative is going to adjust with my quadrant. So in our left hand, using these inverse values, right? This kind of approach of working backwards, I notice that I have 2 fingers above for cosine and 2 fingers below for sine if I'm holding down this middle finger, right? Well, that's the angle that I'm looking for, because cosine is going to be equal to root 2 over 2, and sine is going to be equal to root 2 over 2, which means that tangent of that angle is 1, right? 1 divided by the other. So I'm talking about theta prime equal to pi over 4. Actually, not pi over 4. I am in degrees, so 45 degrees, right? But I'm not talking about 45 degrees because I have a negative right here and because of what quadrant this point terminates in. So I adjust accordingly. If my reference angle, which let me grab another color, if this is my reference angle and this is 45 degrees, how do you work backwards to find theta? Well, you say, what's 180 minus those 45 degrees? And you end up with 135. Okay. It's a little bit of backtracking and kind of, well, how do I get to this? How do I get to this? And I kind of think the most difficult part is finding that angle value for tangent. Okay. So you've got theta is equal to 135 degrees. So that's this right here. Really, that's all we were looking for. Okay.